Good morning, students. I am Puneet Narayan, Assistant Professor, Department of Electronics and Communication Engineering. In previous class, we have discussed the effect of negative feedback on the input and output resistances of the amplifier. In today's class, we'll discuss the effect of negative feedback on the bandwidth of the amplifier. So let's begin. First of all, what is bandwidth? Bandwidth is basically the difference of upper cutoff frequency and the lower cutoff frequency. Now, what is upper cutoff and lower cutoff frequency? For understanding the cutoff frequencies, we have to look into the frequency response curve of the amplifier. This is the frequency response curve of the amplifier. This is the frequency response curve for amplifier without feedback, and this is the frequency response of the amplifier with feedback. Now, wait a moment. Now let us first look into the frequency response curve of the amplifier without feedback. Now, you can easily observe that as we increase the frequency, first of all, gain is basically increasing. Then after some frequency, it becomes constant. And then again it is decreasing. Okay, the constant gain is basically known as A mid, because it is basically gain for the mid frequency region. Now there is a lower cutoff frequency and upper cutoff frequency. What is lower cutoff frequency and upper cutoff frequency? In lower frequency region where gain is increasing, there will be some frequency at which the gain is basically 0.707 into A mid. That particular frequency is basically FL, lower cutoff frequency. And in higher frequency region where the gain is 0.707 A mid, the frequency at which the gain becomes 0.707 A mid is basically the higher cutoff frequency FH. Now, if we introduce feedback into the amplifier, basically negative feedback, if we introduce negative feedback into the amplifier, the gain basically reduces and bandwidth is basically increases. Okay, now our frequency response curve, after introducing the negative feedback, the frequency response curve becomes like this. We can easily observe by this figure that lower cutoff frequency is reducing and upper cutoff frequency is increasing. Okay, but the midband gain has been reduced. Okay, since gain bandwidth product is a constant, so gain bandwidth product doesn't change. By the introduction of negative feedback, midband gain reduces but bandwidth increases. So gain bandwidth product remains constant. Okay, so this is the formula of bandwidth, and this is basically bandwidth with feedback. Bandwidth with feedback is FHF minus FLF, means higher cutoff frequency with feedback minus lower cutoff frequency with feedback. Okay, so now we have to derive the expression of higher cutoff frequency and lower cutoff frequency. In this equation, as you can see, that FHF is the product of 1 plus A mid into beta into FH minus FL upon 1 plus A mid into beta. Okay, but where from these expressions have come? We have to derive these expressions now, because this derivation is a very important derivation. This is usually asked in examination, so we have to consider this derivation in detail. Okay, so first of all, we'll derive the expression for lower cutoff frequency, and after that we'll derive the expression for upper cutoff frequency. Okay, so let's go to the next slide. Now let us derive the expressions for lower cutoff frequency and upper cutoff frequency. For that, first of all, we have to consider first the expressions of various gain. What is gain with feedback? Gain with feedback AF is basically A upon 1 plus A beta. Now there are three gains also: AF mid, midband gain; AF low, gain with feedback in lower frequency region; AF high, gain with feedback in higher frequency region. Now what is AF mid? Similarly with AF, what is AF? AF is A upon 1 plus beta. So similarly AF mid will be A mid upon 1 plus beta A mid. Okay, so what will be AF low? AF low will be A low upon 1 plus beta A low. It's simple. Okay, so then what will AF high? AF high will be A high upon 1 plus beta A high. Okay, so these are our equation number 1, 2 and 3. Now first of all, we'll derive the expression for lower cutoff frequency. Now we know that the relation between gain at lower frequency and gain at mid frequency is given as A lower is equal to A mid upon 1 minus J FL upon F. What is FL? FL is lower cutoff frequency. What is F? F is a simple frequency variable. Okay, so gain A lower is equal to A mid upon 1 minus J FL upon F. This is our equation number 4. Now substituting value of A low in equation 1, we get this expression. Okay, and by manipulating this expression, we can easily come to the conclusion that our FLF is basically becomes FL upon 1 plus A mid into beta. Okay, there is a simple manipulation in these equations. These manipulations are in front of you. You can easily observe and you can easily come to the conclusion that lower cutoff frequency with feedback becomes lower cutoff frequency without feedback upon 1 plus A mid beta. Okay, what it means, what this equation shows that because of negative feedback, our lower cutoff frequency is basically reduced by the factor 1 plus A mid beta. Means lower cutoff frequency is reducing. Okay, now let's go to the next slide. Now we will derive the expression of upper cutoff frequency. Okay, again, as we know, the relationship between gain at high frequency and gain at mid frequency is given as A high equal to A mid upon 1 minus J F upon FH. What is F? Simple frequency variable. What is FH? Higher cutoff frequency without feedback. Now substituting value of A high in equation 11, we get these expressions. Okay, these equations. Okay, now by doing the simple manipulations which are in front of you, you can easily observe and practice these manipulations. We can come to the conclusion that our FHF means cutoff frequency with feedback becomes equal to 1 plus A mid beta into FH. Means the product of a multiplier 1 plus A mid beta and FH. What this equation is showing? This equation is showing that our upper cutoff frequency or higher cutoff frequency is increasing by a multiplier 1 plus A mid beta. Okay, so let's go to our first slide. Now we have derived the expression for higher cutoff frequency. Okay, which is this, and also derive the expression for lower cutoff frequency. Our bandwidth with feedback is what basically? It is basically the difference of upper cutoff frequency or higher cutoff frequency and lower cutoff frequency. Now with the derivation we have just done, we can easily conclude that upper cutoff frequency is increasing by the introduction of negative feedback and lower cutoff frequency is decreasing. So bandwidth, which is basically the difference of higher cutoff frequency and lower cutoff frequencies, is basically will increase. Okay, so this is the derivation which we want to consider in our this lecture. So please do it once and practice it also, because it is a very important derivation and also usually comes in the examination. Okay, so thank you for now. We'll meet on our next lecture with some new topic. Thanks.